Hi guys, I've got a quick aromatic synthesis today. So you start off with salicylic acid. You don't need to remember the structure, it will provide it for you if it asks you to do it. And then 3 different possible reactions. This reaction will produce 2 products, and I'll get onto that in a minute. So we know that it's got a carboxylic acid group, and it's got an OH group. This is a pretty strong acid. This is a pretty weak acid. And this reacts with a weak base of Na2CO3. And as it's a weak base, that means it's not very good at deprotonating, sorry. And so if it's not very good at deprotonating, it will manage to deprotonate the strong acid because it wants to lose this H. It really wants to lose this H. And even though this is weak, it's still strong enough to be able to remove that. But this, it doesn't really want to lose the H too much, and so it's too weak to lose, to be able to lose that. And so that stays as phenol, like that. Now if that reacts with bromine over here, that does say Br2, I know it's not very well written. There was a lot of leeway on this exam, on this question particularly for Br2. You could put the Br absolutely anywhere. All it has to be is just like that, for example. You could even have done more than one substitution. It doesn't matter, as long as you just put a Br somewhere. That's all it is. And then this final one is propanoic anhydride, which looks quite scary. However, it reacts pretty much similarly as a COOH group, as a carboxylic acid group, because it's basically COO, because it'd be CO and then this O. It's essentially, if I draw the structure out, it kind of looks like this. And so, if that makes sense. And so it basically acts as a carboxylic acid. And so all it's asking for is a carboxylic acid reacting with this. And we know it will form an ester with this group. So it's going to be the O from the alcohol, and then it's going to be the C double bond O from here, and then just follow the rest of it. So CH2, and then CH3. So that's one product. And the final product, something that I really would advise just remembering, is when this reacts, it's going to, basically, it's all of that reacts. And if you have a look, what's been lost? The H here. This O comes from there. So the only thing that reacts is that. And so if that H has been lost, it hasn't really been lost, it's gone somewhere else. And if you have a look at it, all of that is reacted. So if I cover that up, what do you have left? You have this group. If you put an H on it, you'll have HO, CO, CH2, CH3, which is also propanoic acid. So when an acid anhydride reacts with a carboxylic acid, not carboxylic acid, an alcohol, it will form the ester, and it will form a carboxylic acid.